over 1.2 domain and range. And similar to my introduction in the previous video, the nice thing is that you've pretty much been talking about this stuff for many years now. So hopefully this will feel very much like a review type of lesson. All right. So in this first part, the key thing I want to remind you again is we're talking about domain being our set of input values for a function, our range being our set of output values for a function. And again, I want your brain to organize that domain. We're talking about the x values, range, we're talking about the y values. So if you just look at these two graphs here, you can see they're talking about the top 5 grossing horror movies for the years 2000 to 2013. And for the domain, they've got 5 movies ranging from I Am Legend, Hannibal, The Ring, The Grudge, The Conjuring. And then we have for the range, we have our lowest value being, looks like just under 150 million, so maybe 140 million, and then going up to almost 300 million, 290 million. Really the difference between these, why I wanted to show you both, is that when you're looking at this, if you were to write down the domain and range for this one in blue, is that you would be using roster notation because it's not a range of values for the domain or the range. You've got set 5 different ones, so that's why you have to use something called roster notation, which we'll talk about a little later. For the one in red, because you're going from 2020 to 2013, including all the years for the market share for horror movies each by year, you could actually use what we've talked about in the past using interval notation. And you'll see that that's the most common one that's used. It's the preferred one for teachers and students. So we'll be focusing on using interval notation. Now, a couple of things to think about before we get into identifying domain range by just looking at the function and also by looking at graphs is that you want to be aware or wary of a couple of things. You want to worry about anytime you see square roots in your function that you're not taking the square roots of negative numbers, because as you learned last year, if you take square roots of negative numbers, that will lead to what we call imaginary numbers. All right, and then you also want to be worried if you see division and your variable in the denominator, because you want to be making sure that you're not dividing by 0. So division by 0 would be something that would worry you, okay? So the way that the book has said to visualize domain and range is to think of the domain as your holding area for your raw materials. Then the raw materials are put into the function machine, and the function machine spits them out, right? So the output as a finished product and puts them into another holding area before they are delivered somewhere. And that holding area after they've been put into the machine is called the range. So if that helps you, great. If not, no big deal. All right. So again, as I mentioned earlier, we try to write as much as we can in this in terms of interval notation. So interval notation. Okay. So let's give you a little bit of the ins and outs of interval notation. Again, hopefully just a quick review. The smallest number from your interval, so the lowest number, is always written first. Right? And we write this on the left. Then the largest number of the interval will go second. All right? But make sure that there's a comma in between. Okay? If you're using parentheses, you're signifying that the value that your parentheses is around is not included. All right, so we say it's excluded or exclusive. All right, and then if you use a bracket, that's to indicate that your value is included, and we say included or inclusive. All right, now infinity, which you guys remember that symbol, and negative infinity. Whenever you use these symbols, they are never going to be inclusive values. They're never going to need or never going to have brackets. So you're always going to use parentheses with infinity or negative infinity. Okay. So now let's just do a quick overview of how you would have seen this back in your Algebra 1 and 2 days. You've got your interval notation. As I said, this is the most important one. You can see it written down as graphs on a number line or a description in words. But we're going to do this. We're going to use this a ton. using our parentheses and our brackets. Don't forget, I just get this every year. Don't forget your lowest number or least number should be first, and your higher number should be second. All right, so let's give a couple examples here. This first one says define the domain of this function, which is listed as 5 ordered pairs. Now, because this is not talking about like going from -5 to 0 to 5 to 10 to 15, it's just listing out the numbers. We actually have to use our roster notation here, which means you just draw your brace and then you list your x values in order from least to greatest: -5, 0, 5, 10, and 15. So you'll notice I did not use interval notation here because we don't have any of those values in between. Okay, so that's called, again, I'll put it here, that's called roster notation. You try to avoid this as much as possible. You'll see it's very, very cumbersome. One thing that helped me when I was in high school was roster notation. Just think of like a class roster that the teacher is looking at. Okay, so let's look at finding the domain of these next two, hopefully using interval notation. So this first one, x squared minus 1. I'm hoping that after we talked briefly about that page in our last section of notes about the parent functions, that toolkit, you should see this is pretty much, I know it's translated 1 unit down, but it's pretty much almost our basic parent function for the quadratic function. And if you were to sketch the quadratic function, right, that looks like our u, and it's moved 1 unit down. So there it is. And if you think about any restrictions on the domain, we can plug in any number we want and square it and then subtract 1. So the domain here is going to be all real numbers. And when we use interval notation, that means -infinity to infinity. Okay, let's go to the next one. The next one is 5 minus x plus x cubed. Key thing is when I see that highest exponent, the degree of my function, being a cubic, I know from my days of being in high school that when I have a cubic function, that any number can work. I can plug in any number for x. It's no problem. So when I see a cubic function, there are no restrictions. This domain is also -infinity to infinity. Okay? Now, let's talk about how to do this when there might be some restrictions. So like in this next example, you might have remember the name of this when you have a variable in the denominator of a fraction. This is called a rational function. So this is a rational function. And we have to be worried. One of the very first things I had you write down on the notes for this lesson is that you need to be cautious if there's a way that you could get 0 in the denominator. And there is a way to get 0 in the denominator. It's to set this equal to 0. So I know I don't want this to happen, but to help me figure out what's going on here in the domain, I'm going to imagine that this were to be happening. So move over the 1, divide by 2, and you get 1/2. Okay, so essentially here I'm saying use any number you want for your input, for your x, except don't choose 1/2, because that would be a problem. So I'm going to write down for the domain, right, I'm going -infinity to infinity. You'll see that I have to do a little bit different here. -infinity to infinity. I don't usually do this. I'm just trying to show you that I'm going all real numbers, but don't use 1/2. Okay? All right, let's do the next page. Now, the next one, all right, is giving us a function that includes a square root. And a square root function, you got to be cautious here, because you know if you take the square root of a negative number, that means it's going to end up being an imaginary number. So you want to be very, very cautious with that. All right, so what I like to do is I want to make sure that when I take the square root of whatever's inside here, it's called the radicand, that it is 0 or more. So I'm going to set my radicand less than 0, because if I get any value less than 0, I know that's an issue. So I'm going to move over the 5 to get -5, and then divide by 2 to get -2.5. All right, so if I have any x values that are less than less than -2.5, I know that I'm going to end up having an issue. All right, so let's pick a number. This will help your brain kind of see what I'm saying. If I pick a number that's less than -2.5, let's choose -3. All right, so if I were to plug in -3, so 2 times -3, you'll see that I'm going to get the square root of 5 plus -6. All right, 5 plus -6 is -1, and you learned in Algebra 2 that the square root of -1 is the letter I. It's an imaginary number. All right, so that's not okay. So when I do the domain here for this square root function, I need to make sure that I'm using values that are -2.5 or greater, so towards positive infinity. So like -2 is fine, -1 is fine, that's fine. So you'll notice I put the -2.5 in a bracket, because if I plug in -2.5, I end up getting 5 plus -5, which is 0, and I can do the square root of 0, that is 0. So -2.5 is what we call included, so it gets a bracket. All right, so here are the other notations again. We'll do an example with set builder and in words, but the key thing I want you to remember is that we're going to be using interval notation. That's our most important one. Okay, so let's try this one in words and set builder and interval notation. All right, so in words, I know it's kind of tougher to see on your notes, but you might look up here and see, or on the screen and see that I have it in navy blue. All right, in words, our values... Try again. Our values for x include any number less than or equal to -2, or numbers between -1 and 3, but not including 3. All right, you'll notice the reason I chose not including 3 was because we have this open circle at that +3. Now, set builder is a little different. All right, you've got your brace. Again, I'm not that worried about this. I'm not going to use it pretty much ever. So values for x such that, and we have x is less than or equal to -2. All right, so values for x that are going to be less than or equal to -2. And then here we'll have values that are between -1 and 3. Maybe make this a little nicer. There we go. Okay, and then finally, so you can see the break here. The last one, which is the most important one, interval notation, is going to be -infinity to -2, and then we have -1 to +3. All right. The key thing for that, all right, is to make sure that you see that it's easily the simplest one out of all of them. All right, but you definitely have options if that's what you want. Okay. All right, let's keep going. I think I wrote this wrong. Let me try this again. And I said x is less than or equal to -2. That's what I said. That's not what I wrote. There we go. That makes more sense. Okay, let's identify the domain and range from a graph. So again, domain, you want to be thinking your x values, reading it from left to right, and range are your y values from bottom to top. So I always tell students to read this like a book. You're going from left to right. Okay. In terms of the range, you're going from the least greatest to the lowest number, the least number to the highest number. All right. So let's do the domain. Domain looks like our lowest x value is -5, and it is included. All right, because we have that closed circle. And then all the way, and this arrow is going this way forever. All right, so that means we're going to be going to the right forever. So that's going towards infinity. So that's the domain. Let's try the range. The arrow is going down. All right, so I know that felt like the last thing we do with the domain, but because the range goes from bottom to top, the first thing actually is that down piece, which is going down to -infinity. And then the highest y value is going to be this point again, which you look, the y value is a +5, and it's included. All right, just a coincidence that it's like opposites there, 5 and -5. It doesn't have to be that same number. Okay, let's keep going. Almost there, a few more pages. Now for this next one, all right, for the domain, right, again, from left to right, you've got -3, but it's not included. We do have an open circle, and moving to +1, all right, I'm using that bracket there because it is included at +1. For the range, and this can be a little tricky, the lowest value is happening twice, right, at that -4. All right, but watch this. The highest value is happening twice. I mean, really once, but it's happening twice. You see open circle and you see closed circle here. And I've told students in the past that if you have a point where one of them is open and one is closed, it's at the same value, then the closed will always win out. So actually, this y value of 0 is going to be included as our highest value of the range. Okay? A different example with world population increase. All right, our domain is going to be from 1950 until the year 2000. And then our range, our lowest value looks like it's, I think I said roughly 46 million people, all the way up to, looks like it hits the highest value of 90 million up there. Again, if you wrote 45, 46, 47, something around there, I would accept that. But both of those need to be included, so brackets. All right, now, what you can do to help if you're having any issues with this is you can always go to any calculator to graph them. I put here, you can always go to decimals.com. It's on your phone. You can use the TI-84 on your phone. We got lots of different ways to graph this. I know a lot of these already because I've been doing this for so long to do them without the graph, but I will show you graphically the way to do this. But just to be, frank with you guys, letter A, the first moment I read f of x equals 2x cubed minus x and see that cubic function, I know that this domain at range will be all real numbers for both of them. So 2x cubed minus x. All right, you can notice that we don't have any restrictions. These are all just values we'll talk about another time. They're x-intercepts, roots, relative minima and maxima. And you can notice that it's just going all the directions, both ways, no issues. So domain and range will be -infinity to infinity. And you can take that to the bank for any cubic function. Okay, now letter B. I already know letter B is going to be a problem, right? Because I see that variable in the denominator. As I said earlier, this is a rational function. So I'm worried that if I set that denominator equal to 0, I can't have a value of -1. So I know for my domain, it's going to be all real numbers, except, this is where I like to do this just to show you. I don't do this normally, but again, I think it might help you. I'm going from -infinity to infinity, but I cannot include -1. So let's show you what that looks like for this second example, 2 over x plus 1. So I have 2 over x plus 1. And if I were to graph x equals -1, and I'll change it up, you don't have to do this, but if you change it up to look a little different, you might notice what this is, that dotted line. Let's go to that one. All right, you might remember me talking about this in a different year where your teacher in Algebra 2 Algebra 2 or Algebra 1 telling you that this is called an asymptote. So we have a vertical asymptote at x equals -1. All right, but now if you look at the green curves, you notice is that we're getting closer and closer and closer to the x-axis, but never touching it. So y equals 0 is actually the x-axis. Change the colors, change the look like that. And you might notice that that is called the horizontal asymptote. So we'll be going over this again, don't worry. But this has a vertical asymptote at x equals -1 and a horizontal asymptote at y equals 0, which you guessed it is going to influence what I write for the range. So the range is -infinity to 0 and then 0 to infinity. All right, the last one here. Looking at the domain and range of this square root function. Again, as I did earlier in these notes, I'm worried that 2 minus x is going to be a negative number because I can't take the square root of a negative. So if I were to solve this, I get 2 is less than x, or values for x are greater than 2. Let me do it like this. I think it'll be easier for you to see. So move that over, and then I have to switch our inequality symbol because we're dividing by a negative. So x is greater than 2. So I'm worried that if I have any values greater than 2, then it's going to be an issue, right? If I plug in 3, 2 minus 3 is a negative 1. I can't take the square root of a negative 1. So for my domain, I'll show you graphically here in a moment, my domain is going to be negative infinity to 2. And I'm going to include 2 because 2 minus 2 is 0, and I can do the square root of that. All right, for the range, let's get that by the graph, and I'll confirm the domain with this graph as well. So the opposite of the square root of 2 minus x. So we have the opposite of the square root of 2 minus x. All right, so you can see my domain, left to right, negative infinity to that positive 2. And then for the range, we're going negative infinity up to the highest y value, which in fact is that y value of 0. So the range is going to be negative infinity to 0. And 0 is included. You might be wondering why this looks kind of off. Again, most of the time when you deal with square roots, you're going from a number to infinity. But because of that negative, right, that has flipped the parabola. Let me show you. Right, that's flipped it, and that's caused it to be look a little different with our notation. All right, almost done. Talk a little bit about piecewise functions, then we'll be finished. We did a little work with this in Algebra 2, talking about ways you can put different pieces of functions together to be one function. All right, and the key thing here is that you interact with these all the time in the real world. You know, I have lots of children, so when I take them to places that I have to pay, money for them to enter, that's an example of a piecewise function. So look at this one here. A museum charges $5 per person for a guided tour with a group of 1 to 9 people, or a fixed $50 fee for a group of 10 or more people. Write a function relating the number of people n to the cost c. So we have c of n equals, and you do a big giant brace. All right, and it's $5 per person, so 5 times n, if your number of people is between 1 and 9. Okay, and then it's a fixed $50 cost, so you don't have to multiply by anything because it's going to be $50 if the number of people is 10 or more, so greater than or equal to 10. Okay, so that's an example of a piecewise function that you encounter all the time. I used to always think, for me in high school, the easiest piecewise function was like the ticket prices at a movie theater, right? It cost me different than when I go than when I take my dad, who's at this point old enough to qualify for the senior rate. Okay, let's graph a piecewise function, and then we'll be done. Just to let you guys know, to be honest here, this one is a little bit looks a little bit different because we don't have any included values for -1 and 4. I'll repeat, most piecewise functions are going to pick some of these inequalities to have the or equal to. So I'm going to just do this to make it easier for us. I'm going to make this one the or equal to and this one. So if I were to start with the first piece and do values that are less than -1, I could do any number I want, but a lot of those numbers will be off the grid. So if I do -2, -2 cubed is -8. Let me do this to help you all do different colors. So I'll do red for this first piece. So here, this first piece is red. So -2 and -8. All right, and when I do this, I always break the rules. When I taught Algebra 2, kids used to be like, oh my gosh, you're going to break it. I was like, yes, I'm going to. I'm going to plug in -1 into this first piece, but I'm going to make it an open circle. So -1 cubed is -1. Now, I'm going to go to the next one with blue. All right, so the second piece is blue. And it says if it's between -1 and 4, it's going to be -2. All right, so between -1 and -4, so I have -2 all the way, and then 1, 2, 3, 4. But this piece is not going to be included, so I'm going to do an open circle. Remember, break the rule at +4 for the x. And finally, my green piece is going to be greater than or equal to 4. So I have the square root of 4 is 2. And then another one that's on here is the square root of 9. Square root of 9 is 3, and that's going on forever. All right, again, if you're interested, I can show you guys in class of how to make this on Desmos if you want to. Oh, actually, let me finish the red, sorry. I can show you how to make this, with technology. But the key thing is to know that it's going to look like different pieces because it's called a piecewise function. All right, so that's it for the second lesson. Good luck on your practice.